Welcome everyone to Algebra 2, Chapter 6. We're starting with Section 6.0. But first in Chapter 6 we're talking about polynomial functions. And to start out we're going to get into quadratics, which are functions with an exponent of 2, highest exponent of 2. And we're talking about other polynomials from there. And you notice that there is no Section 4. So we're going to have 1, 2, 3, 4, 5 sections and then our test. So now, I don't need those, just need my presets. There we go. So now as we look at the notes for today, talk about a parent function of the quadratic. So f of x equals x squared. Remember that's the same thing as y equals x squared. So we're saying no changes have been done to this. Well, if we take this table of these 5 x values and plug each of them into x and get our y out, we would get 4, 1, 0, 1, and 4. So then you would graph those accordingly and connect those points, and you get that U shape that we say all of our quadratics have. So then we're going to say, and all quadratics will look like some sort of U shape, whether it's up or down or stretched or compressed or translated left to right, up, down, anything like that. But our parent function is at the origin going up and is not stretched or compressed at all. So the axis of symmetry of parent functions. Well, wait, what is an axis of symmetry? Axis of symmetry, or I will abbreviate it AOS, is where it's cut in half. So if you look at it from here, if you take this side and this side, they're just mirrors of each other. So if you were to take one and flip it over to the other side, like you're folding a piece of paper, they would overlap each other perfectly. So the axis of symmetry is x equals some number, if x equals a number, and it's going to be x equals 0 in this case, because every x value is 0 left or right, aka that is also the y-axis in this case. And the vertex, the lowest point or highest point where it changes direction, is 0, 0. The domain of the quadratic function is always negative infinity to positive infinity. The range of a quadratic function is negative infinity to the y of the vertex. Or, depending on which way the quadratic opens, ran out of room, wrote too big, the y of vertex to infinity. So here in this case, when it opens up, you see that the range is going to be on the low end is that y of the vertex, and on the high end is the infinity. So it'd be the second one over here, because it always goes from low to high. And so because it never stops going up, infinity is second. Whereas if it was opening like down like this, it'd be the first one. Standard form of a quadratic. We've talked about this a little bit. It's y equals ax squared plus bx plus c. So we have the a, b, c, and we have it in order of x squared, x, then no x, as far as decreasing those exponents. And we say the graph opens up if a is bigger than 0, which means it's positive. We've talked about this last semester a little bit, obviously more than a little bit. We talked about it with quadratics, and we talked about it with absolute value quite a bit as well. And if a is less than 0, it opens down, which would mean that it's negative to start off. So here on our parent function, a is a positive 1 in front of the x squared. So it's positive, so it opened up. The axis of symmetry, how to find it from our standard form, is x is equal to negative b over 2a. Whoa, okay. So we said it's x equals to some numbers or axis of symmetry because it's always a vertical line. And how we find it is we take from our a, b, c, in this case just our a and b, you do the negative of the b value divided by 2 times a. I'll go through some examples. To find the vertex from the standard form, you plug in the x you got from the axis symmetry, plug in x from, and I'm going to abbreviate axis of symmetry to AOS to get the y. And then you'll have your x comma y for a point. To find the y-intercept from your standard form, you plug in 0 for x, because remember, an intercept is where the other variable is always 0. And then you say, okay, it's going to be actually just the plus c part at the end. All right, so let's put this into practice. So we're supposed to graph this function by identifying axis of symmetry, the vertex, and the y-intercept. So we are supposed to find 3 different parts here. Axis of symmetry I'll do in red, the vertex I'll do in blue, and then the y-intercept I'll do in orange. So for the axis of symmetry, AOS, I'm going to go ahead and label it. You don't have to, but it might be a good idea so you remember what part you're doing when. So it's x is equal to negative b over 2a. In this case, that would be negative of 2, which is the b, over 2 times negative 1, which is the a. Well, negative 2 over negative 2 is what that would simplify to, so positive 1. So the axis of symmetry is x equals 1. So that means that's the vertical line that's going to reflect over. So it can be a good idea to draw a dashed line over that, but you don't have to. I'm going to go and label it, but once again, you do not have to. It might be a good idea on your notes so you can remember what is what. That, hey, this is my axis of symmetry, which I am calling AOS, because I'm lazy and don't want to write all that out. Now for the vertex, it says we plug in x from the axis of symmetry to get y. So you take your equation, y equals negative x squared plus 2x minus 4, and say, instead of x, we're going to plug in 1 from our axis of symmetry. So negative of 1 squared plus 2 times 1 minus 4. So that ends up being negative 1, because 1 squared is 1, and you make the negative after you square, plus 2 minus 4. Negative 1 plus 2 minus 4 is going to be negative 3, making my vertex 1 comma negative 3. I'm going to go ahead and box these as well, so that way, hey, I can see where I kind of finished off each one. So that's a good idea to graph that point, 1 to the right, 3 left. And now I need to find the y-intercept. In order to find the y-intercept, it says it's going to be 0 comma c. So 0 for the x value, and what's the c? It's negative 4. So negative 4. So I can graph that point. Now, we know that this is the vertex right here, this blue point at 1 comma negative 3. And because a is a negative, it opens down. That's a good piece of information to take from this. I'd encourage you to write that down as well. Write down as many facts from these as you can, and you can use all these facts to help you graph. So we know it's going to look something like this. We just got to figure out where. Well, now we kind of have this idea over here, and we can just mirror it on the other side. So because it went from our vertex 1 down and 1 left, we can go 1 down and 1 right. And mirror it over here. And boom, we have our quadratic. Quick recap on what we did is we found the axis symmetry by following through the x equal to negative b over 2a from our a and b here. Got it to be 1. So we made our dashed line here. Said, okay, that's going to cut it in half. Then we found the vertex by plugging in x from the axis symmetry to get the y. So we plugged in x and we solved for y. We said, hey, that's our vertex now, x comma y, so we plotted that. And last but not least, we did the y-intercept by making x 0, which in this case made the y value just the c. So 0, -4, because that was c, and we plotted that. We said, hey, it's going to mirror or reflect perfectly over this line. So let's make it mirror or reflect perfectly over this line. And it opens down, we said. We knew that as well because it starts off negative. So that's a little hint for us as well that, hey, it did end up opening down for us. That's a good thing. All right, on to the next part where we're going over vertex form. Vertex form, excuse me, let me go back to this one real quick. I got ahead of myself. I also wanted to talk briefly about the domain and range of this function. Even though it doesn't require us to, you'll be asked to find that later. So the domain, how far left and right it goes. We said earlier, the domain is always going to be negative infinity to positive infinity because it never stops going left and it never stops going right. And those are parentheses because it can't get to infinity. The range is going to be, it never stops going down, so it's negative infinity. And it does stop going up right here. The highest it gets is -3, so that's a bracket. And that would be our domain and range. Now when you're graphing quadratics, you always want 3 points at least. You typically want your vertex, you always want your vertex, and then a point on either side. And if you find one, you can just mirror it to find the other. Now let's go to vertex form of a quadratic. So the vertex form is y equals a times x minus h squared plus k. I want to note that, hey, this is very similar to the absolute value function. Absolute value, if you recall, was y equals a times the absolute value of x minus h plus k. Where he said h was how far left and right, and it was the opposite sign. K was how far up or down. And a told us whether it opened up or down, depending on if it was positive or negative, as well if it stretched or compressed, depending on if it was a number bigger than 1 or -1 or between 1 and -1. All right, so again, the graph opens up if a is bigger than 0, aka it's positive, just like before. And it opens down if a is less than 0, aka if it's negative. The vertex from the axis symmetry, or excuse me, the axis symmetry from vertex form, I should say, is much easier. It's x equals h, because this tells you how far left and right you go. And remember, you do the opposite sign of what you see. And we'll cover that in the example we do. The vertex from vertex form, as the name suggests, this is an easy way to find the vertex when it's in this form, is just going to be h comma k. How far left and right, how far up or down, we translated. The y-intercept is a little more complex than it was in the standard form, where you plug in x equals 0 and then solve for y. And then you still do the x comma y, aka 0 comma whatever your y value was, because your x value was 0. So let's go ahead and do example 2. We're supposed to graph this function in vertex form here because it has the a in front like it did before, but now your parenthesis squared plus or minus a number at the end, compared to standard form, which was x squared bxc, no parentheses, where this is a parentheses being squared with something being added or subtracted at the end. And we're supposed to identify the axis symmetry. I'll do that in orange. The vertex, I'll do that in blue. And the y-intercept, I'll do that in green. So axis symmetry is going to be very straightforward on this one, where you just do x equals h. Well, it shows a -4, so I do the opposite and I call it +4. Boom, I found my axis symmetry just like that, because that tells me, hey, I go 4 to the right. So 4 to the right, and I'm going to draw that dash line going down. Now onto my vertex. This one's also nice and straightforward on this one. You just do 4 right, because it's the opposite, and 1 up. This is exactly what it says. 4, 1. And plot that point, and boom, we have a vertex. The y-intercept, like I said, was a little more complex on this one compared to the last one, where it's just 0, c. You take your equation or your function, y equals 1/4, and instead of x, you put in 0. 0 minus 4 squared plus 1. So 0 minus 4 is negative 4. If we square that, we get positive 16. Now 1/4 times positive 16, and do that work off to the side, you're more than welcome. But otherwise, you can put 16 over 1, and they reduce to 4 and 1. So you get 4 plus 1. I don't know why I did that in blue. So y equals 5. So since we plugged in 0 for x, we do 0, 5, x, y. And we plot that point. 1, 2, 3, 4, 5 up. And now we have 2 points. So we have the vertex, we have a point on the left, now we just need a point on the right. So how we do that is we say, okay, we went left from the vertex 1, 2, 3, 4, and up 1, 2, 3, 4. Well, that was weird. So we're going to go right. 1, 2, 3, 4, and up 1, 2, 3, 4. And just mirror it. And now we have our quadratic. And you see the 1/4 out in front changed the way this one looked. It made it appear wider, or like it was pushed down, aka compressed. Now, on this one, I also want to note that, hey, because it was a positive, we should have known right away it was going to open up. So if we got anything different than it opening up, that would have been an issue. I will note that the domain, once again, is forever to the left, negative infinity, and forever to the right, positive infinity. The range has a lowest point at 1 and a highest point never, so at infinity. And it doesn't get to infinity, but it does get to 1. We weren't asked to identify the range and domain still, but I'm doing it because we will have to do it later, so I'm going to have notes of it. So a quick little recap on this one before I move on to the last one is that because a was positive 1/4 instead of a negative, it opened up, which yes it did. Then for the axis of symmetry, we did x equals h, so it was -4, so we did +4. That's where our dashed line is that it reflects over. The vertex is h, k, so we said positive 4 is opposite, and the same positive 1. 4, 1 is a vertex, plot that point. Then, really honestly, in my opinion, the only complex about this, but you might find other things to be complex about it, and that's okay, is the y-intercept. Because you plug in x equals 0, solve for y. So we took our original equation, made x 0, started solving, and got it to be 5. So then to find our other point, since we had 2, was we just said, okay, how far from the vertex was it? Well, we went left 4 and up 4. So you go right 4 and up 4 and do the same thing. All right, our last form we're going to talk about is the intercept form. The intercept form is y equals a again times the first parenthesis x minus p, second parenthesis x minus q. So once again, graph opens up if a is greater than 0, aka if it's positive. That doesn't change on any of these, you might notice. It opens down if a is less than 0, aka it's negative. The x-intercepts is what you're going to want to graph from intercept form, hence intercept, intercept. Just like last one, the vertex was easy, and the vertex form are going to just be p comma 0, because the intercept always has the other variable as 0, and q comma 0. You might notice p and q come from those parentheses next to x. And those are still going to be opposite signs from what they were in the parentheses. So if you see a plus a p, it's really going to be negative, or vice versa. The axis of symmetry from the vertex form. It's a little more complex than it was before. Remember, I'm abbreviating axis of symmetry as AOS. It's x equals p plus q, so you take your intercepts and add them together, and divide by 2. So it's like you're finding the average of those. Now to find the vertex from this form, you, just like we did for standard form, plug in the x from the axis of symmetry, and solve for y. And you call your answer x comma y. All right, now for this, on this one, we're supposed to graph this in vertex form with our two different parentheses. That's how you notice this form is different. Identifying axis of symmetry, which I'll do in green, the vertex I'll do in orange, and the x-intercepts I'll do in blue. So I'd argue here that the fastest one to do is x-intercepts, but it really doesn't matter which one we do first. And we can note right away that, hey, since this is negative out in front, is it going to open up or down? It will open down. So we can go in any order, whether you start with your x-intercepts, or you start with your vertex, or if you start with your axis of symmetry. So let's say we just start with our axis of symmetry because we have on every other one. Well, x equals p plus q over 2. Well, p, not negative 1, but it's positive 1 because it's the opposite, and q, not in positive 3, but negative 3. So 1 plus a negative 3, or 1 minus 3. It's the same thing whether you say it's plus a negative or minus over 2. So it's going to be negative 2 over 2, which is negative 1. So the axis of symmetry is that x equals negative 1. For the vertex, you take that and plug it into the equation. So y equals negative 2 times negative 1 minus 1 times negative 1 plus 3. And from there, simplifying each parenthesis, you get negative 2 in the first parenthesis and positive 2 in the second parenthesis. So you have negative 2 times positive 2, which gives you a positive 8. So your vertex is negative 1 comma 8. Negative 1 from the axis of symmetry, and the 8 from what you plugged in, or you got from plugging it in. So it goes 1 left, and it goes 8 up. And last but not least, the x-intercepts, you just take the p and the q and put them comma 0. So 1 comma 0 because you do the opposite, and negative 3 comma 0. And that's your x-intercepts, just like that. So we found our axis of symmetry, we found our vertex, and we found our x-intercepts. So what you do for those is you go 1 comma 0, excuse me, that's 0 comma 0, and negative 3 comma 0. Now you might notice that those are exactly 2 points away from the axis of symmetry. It'll always happen that the intercepts, the x-intercepts, are both the same distance from the axis of symmetry. AKA, the axis of symmetry will always be directly in the middle of our 2 intercepts because it has to be symmetrical. So now we connect these points and hey look, it does open down, so we'd be done. Now before I end these notes, because that was our last example, I want to recap this one real quick as well. So we know from it being a negative to start that it's going to open down, which it did. We know it's in vertex form because it's 2 separate parentheses. Then identifying the axis of symmetry, like it said up here, we took x equals p plus q over 2. So we said p was a positive 1 and a q was a negative 3 because you take the opposites. and divide those, combine them and divide by 2. So we got -1, so that's where our dashed line is. Then, for the vertex, we plugged in the x from x symmetry and solved for y. So you plugged in -1 as your x in both spots, simplified, and got y equals 8. So it's -1, comma 8. Then, last but not least, for the x-intercept, you just said p comma 0, q comma 0. So +1 and -3, 1 comma 0, -3 comma 0, graphed them, and called it good. So that is section 6.0. I know at the top of the screen it says 6.1. Sorry, I need to fix that. But it is section 6.0. So go ahead and work on that worksheet today, and then you will be done for the day.